Welcome to the Process Technology program. I'm Brian Aries, one of your instructors. I graduated from this program in 2011, then spent 9 years at Shell Puget Sound Refinery as an operator, fire team member, and FCCU trainer. I know what it feels like to sit where you're sitting. This program opened a lot of doors for me, and I'm glad you're here. Operators work in refining, power generation, wastewater treatment, food processing, paper mills, chemical plants, and many other industries. Operators mainly control 5 things: pressure, temperature, level, flow, and chemical reaction. Pumps and compressors affect pressure, boilers, furnaces, and heat exchangers affect temperature, tanks hold levels, pipes and valve systems control flows. There are a lot of places that these skills can take you. The local refineries are a major option, but they're not the only option. Keep an open mind as you move through the program. Most operators start by learning equipment in the field. Outside operators make rounds, take samples, check equipment, start and stop pumps, line up valves, watch operating conditions, and prepare equipment for maintenance. A good operator learns what normal looks like, sounds like, and smells like. As you gain experience in qualifying more equipment, you take on more responsibility. A lead operator coordinates work, issues permits, responds to process problems, and helps manage startups and shutdowns. They're often the person that everyone turns to when they really need to know what is happening on the unit. Console operators run the process from the control room. They communicate with outside operators and lead operators over the radio. They may be watching hundreds of pressures, temperatures, levels, flows, alarms, and controllers. The computer gives you information, but you still need to understand the equipment behind the screen. Operations roles can lead in a lot of different directions. Operators move into training, safety, supervision, process specialist roles, turnaround planning, lab work, and management. You don't have to know exactly where you're headed yet. Start by becoming good at the job in front of you. Safety is built into everything that operators do. Here in the program, you'll learn personal safety, process safety, chemical hazards, PPE, environmental responsibility, stop work authority, and safe operating practices. In industry, getting the job done matters. Getting everyone home safely matters more. Some operators also serve on emergency response teams. I was on the refinery fire team, and those experiences taught me a lot about preparation, communication, and staying calm under pressure. Depending on the facility, operators may help with firefighting, medical response, spill response, hazmat, or rescue. A lot of process facilities run 24/7. That means days, nights, weekends, holidays, and rotating shifts may all be part of the job. Shift work has challenges, but it also provides longer stretches of time off. Every industry and employer is a little bit different. This is a real example of from my schedule in 2019. Notice that the days marked in blue are night shifts, orange are day shifts, and white are days off. So at the time when I took this screenshot of my schedule in 2019, without adding overtime or training for the remainder of the year, I was scheduled to work 122 days off, 122 days with 133 days off. That amounts to working a little bit less than half of the days, and that was a pretty good schedule. You've already made it through admissions and registration, so now the real work begins. Show up, participate, ask questions, complete the work, and get into the lab and practice. The program will give you opportunities, but what you get out of it depends heavily on what you put into it. By the end of the program, you'll be able to operate equipment, monitor processes, troubleshoot problems, read diagrams, PNIDs, and work safely. You'll study flow, heat, chemistry, electricity, equipment, instruments, and control systems. Nobody expects you to know it all today. We'll build it one step at a time. There are a lot of great career opportunities in process technology, and many of them pay very well. A certificate or degree by itself does not make someone a strong operator. Employers are looking for people who are dependable, interested, willing to learn, able to work with others, and ready to step in and help. This is the Desmond McCardle Center, where most of the PTEC classes and labs will take place. You'll hear us call it the DMC. This is where we start connecting what you learn in class to actual equipment and operating situations. When you first walk through the building, some of the equipment may look unfamiliar or a little overwhelming. That's normal. Before long, you'll start recognizing pumps, valves, instruments, tanks, piping, and control systems everywhere you go. This is part of the first year lab. You'll begin working with pumps, tanks, piping, valves, instruments, and control loops. The equipment is smaller than industrial equipment, but the basic principles are the same. This is the second year lab. In the second year lab, the systems become more complex. We don't strictly adhere to first year and second year labs. We'll work in both, but these are more complex systems on this side of the lab. By the time you reach your second year, you'll be expected to do more than identify equipment. You'll operate the systems, troubleshoot problems, follow procedures, and explain what is happening. This is the tool room and control board. These areas include tools, equipment, control systems used throughout the program. Take good care of the equipment, put tools back, and keep your workspace clean. Those may sound like small things, but in the industry, they say a lot about your professionalism. These are some of our lab scale units or control loops. This is where you'll see how an instrument measures process, how a controller responds, and how a valve changes the operating conditions. Pressure, temperature, level, flow, and chemical reactions start making a lot more sense when you can actually see them change. This is a demonstration of what happens inside of a distillation tower. Vapors move up, liquids move down, they contact each other, and the products separate based on difference in boiling points. You don't need to understand every detail yet. We'll get there. Some of your learning will happen in the classroom through presentations, discussions, videos, readings, and simulations. The classroom gives you the foundation. The real value comes when you connect that information to the equipment, operating decisions, and hands-on practice. Cutaways let you see what's happening inside the equipment. In the field, you may only see the outside of a pump, valve, or compressor. Understanding what's inside helps us understand how the equipment works and what may be happening when it doesn't. You'll work with a variety of trainers throughout the program. The goal is not just to memorize the names of the equipment. You need to understand what each piece does, how it affects the rest of the process, and what could potentially go wrong. Operating is a team profession. Operators work with other operators, maintenance, electricians, instrument techs, engineers, lab personnel, supervisors, and contractors. Having technical skill is important. So is being dependable, helping others, listening, communicating, and taking an active interest in what is happening around you. I'm glad you chose process technology, and I'm looking forward to working with you. This program really is what you make it. You can do the minimum and earn some credits, or you can participate, ask questions, practice, help your classmates, and build a reputation as someone people want on their team. That second path is where the real opportunities come from. Welcome to PTEC 101 and the Process Technology program.